I had to check your lecture grade manually. It takes long time. I work 6 to 8 hours. The reason that last weekend I took the same day, that's why it was showing the grade. I think this is the reason that they didn't show you the grade. I had to make it penalty. Yeah, it's too tough, too tough. 100, yeah, 99, 100 grades. I did manually. Oh no, my this hand is still hurting non-stop computer working. Yeah, I think you guys can see. I think I did Friday. I think I did Friday. If you guys have any question, anything, you guys can obviously ask me. Yeah. So let's move on. So please practice last time what we learned, and let's go back to the today's lecture from here. So we now know that why we do the balancing of chemical reaction and why we need it. Also, we have already learned that from the balancing of chemical reaction, we can learn the mole amount of reagents and product. We can also learn that we can calculate different mole or gram amount from this equation and help of the ratio of mole of between the reactants or between the reactants and products. Today we are going to learn more additional information that we can have from this reaction. Let's look into first that what does this equation mean? As I said, that here uh, to make 2 mole, and in this presentation slide, N means mole, okay? 2 mole of ammonia, we need 1 mole of nitrogen and 3 mole of hydrogen. When 1 mole of nitrogen reacts with 3 mole of hydrogen, we can produce 2 mole of ammonia. We have already learned or talk about that any kind of ratio or any kind of mole amount we can calculate if we have the standard balance ratio. So now if I ask you that how many mole of hydrogen and nitrogen we need if we are going to make the 5 mole of ammonia. So we can make it, correct? So we will make our ratio between ammonia to hydrogen or ammonia to nitrogen, and then we will multiply the conversion factor with the 5 mole. Then we will find the amount. So here, along with those information, we are going to learn something else called the limiting reagents or excess reagents. So first of all, this is kind of review because you guys remember that we had 1-2 math and I already explained the ratio and I also gave you the supplemental materials. So here I want to review those ratio that the chemical equation provides a combining ratio that is always the same. So just on the basis of the ratio, like here we go. Like this ratio between the ammonia and the hydrogen, if we look into here the ratio between the ammonia and nitrogen. So the standard ratio will be the same, but we can make or change the ratio or amount what we need to make this reaction in the laboratory or in the chemical industry. Chemical industry or pharmaceutical industry, they need the large scale, but they calculate the ratio from here because this is our principle. As we said that today we are going to learn about the limiting reagent or excess reagent. First, let's make some basics, whatever the example we have here. Now let's consider that we have here 4 jars and 3 lids. So now it's very simple that if you have 4 open jars and 3 lids, how many closed jars you can make? how many closed jar you can make. So obviously first you have to close the jar with the lid. So here we have 4 and 3 lid. So obviously we will have 3 closed jar and we have to left this one. So this one will be the leftover jar. So limiting reagent is the reagent that you run out of first limit the amount of product that you can make. Let's make it more easy. So let's think is that here. If we don't have the fourth lid, we cannot close the fourth container or jar, correct? So let's see that A and B is a two reagent, A, B combining and making C. But if you run out A, can you make the C anymore? No. So in that moment, A will be the limiting reagent. Got it? So which reagent will finish faster? So this is how they try to say here that if you don't have the sufficient lead, it doesn't matter how many open jar you have, you can only make these 3 or how many lead you have, correct? Like if you have a 6 jar and 4 lead, so you can only make 4 closed jar. It doesn't matter how many open jar you have. So that means when lead will be consumed, you cannot make any more closed jar, correct? So in case of a chemical reaction is also, if the reagent is finished, how you are going to continue the reaction, correct? And make the product. So this is called the limiting reagents, which will be consuming fast. Now look into here, we will now do the detail. Chemical reaction is a recipe for a chemical equation is a recipe for the chemical reaction. So we know now here the 1 mole of nitrogen, at least we need 3 mole of hydrogen to produce the 2 mole of ammonia. Now, if I ask you that I need to make this is 3 mole of hydrogen. So 30-90 means the ratio is 1:3, correct? So now if we don't change this amount, look into here, if we don't change this amount, but we increase the amount of hydrogen, so what will happen? The product will be same. Why? Because this amount of nitrogen minimum we need to react with this amount of hydrogen, correct? If we are increasing hydrogen and we are not increasing here the nitrogen, then the product amount will be same. When hydrogen will be excess, but if we don't have nitrogen, it cannot make more ammonia, correct? Similarly, look into here. Let's first delete the annotations. Similarly, look into the here. We have increased little bit of nitrogen, but we keep the same ratio, I mean same amount of hydrogen. It also doesn't make sense because if you have the excess nitrogen, but if you don't have the excess hydrogen, you cannot even make the mole because the ratio between the nitrogen and hydrogen is 1:3. So if you have 1 mole nitrogen, you must have to have 3 mole hydrogen. So now you are increasing little bit, let's see the 1.25 mole or something nitrogen, but hydrogen is same 3 mole. So 3 mole hydrogen can only react with the 1 mole nitrogen, correct? So in that case, hydrogen will be the limiting reagent. Now my question, do you guys got it? This is very simple, but you have to got it. So the thing, if still not, let me know. The thing is that any type of, even if we are doing the cooking recipe or something, the thing is same. We know that we put some salt, we know we put sometimes sugar, we put sometimes other reagents. But if we cannot put the right amount, the perfect taste will not come. Correct? Here we go the same thing. So we have the same ratio, fixed ratio for particular reaction. But if we change their ratio according to that ratio, then the product will be enhanced. For example, if we increase 2 mole nitrogen and add the 6 mole hydrogen, then we can say that double production will become here, correct? Because for each 1 mole, we need 3 mole hydrogen, got it? For each 1 mole nitrogen, then we can prepare minimum 2 mole amine. So this is our starting amount for this particular reaction. So that means that if you look into here, that nitrogen and hydrogen, the particular reaction I am reviewing again, that if we don't change the nitrogen, but if we change the hydrogen, product the same, because if we don't have the excess amount of nitrogen to react after 3 mole of hydrogen, whatever the leftover hydrogen we have, we will not have product. Similarly, if we increase the amount of nitrogen, but if we keep the same amount of hydrogen, still it will not make the excess product. And here the limiting reagent will be hydrogen instead of nitrogen, because we don't have the excess amount of reagent. So the final talk is that which reagent will be first consumed or first finished, that will be the limiting reagent. Okay? So next move on. In a chemistry laboratory, you don't always mix the exact ratio of reactants that are needed. So the limiting reagent is the reactant that runs out first during a reaction. This reaction is completely consumed and all used up. Now got it? From the example you clear? Now another term we have is called the excess reagent. Excess reagent is the one that does not run out. Let's go back to see here. In this particular reaction, 30-90 is the ratio for the reaction. So 30 and 90 will be used up and 10 mole more nitrogen will be remaining, correct? So in this particular ratio, the nitrogen will be the excess reagent. If we look into here, 30-90 is the 1:3 is our reaction. So 10, almost 10, little bit of more than 90, correct? This is 100. So in this ratio, the hydrogen will be the excess reagent. So in a simple term, the reagent is consumed or used up first, that's the limiting reagent, and the reagent will be remaining after the reaction or excess amount, that we call the excess reagent. Yeah, the balanced chemical equation allows us to compute the reactant consumed, reactant leftover, and the product produced. So, from the balancing of reaction, we have all the information. Now, you will have some mathematics problems. Some are very straightforward, some are long step. But if you clearly understand the ratio of the balancing reaction, how we calculate during the run of chemical reaction, then it doesn't matter how big the equation, you can able to do that. But that's why I'm repeating and asking that, are you guys clear? Because if you guys are not clear about the ratio of between the reagent or ratio between the reactants and reagents and products, it will be tough when you will do the math problem. Let's see the basic limiting reagent math problem. If I have 3 moles hydrogen and 1.7 mole oxygen, how many mole of water you can make? Interesting. You remember when I teach you first time that using the ratio of mole reagent, we provided you the chemical reaction, correct? In this chapter, a little bit of advance, that sometimes you may need to write the reaction and balance the equation. Got it? Sometimes. But normally we give you, but still be prepared, because now you know how to do the balance, correct? So your job first to balance the chemical reaction. Then figure it out how many mole of water we can make. So our reaction is this one. So hydrogen plus oxygen, that combined make the water. Now the ratio of hydrogen and oxygen, 2:1. So that means 2 mole of hydrogen we need to react with 1 mole of oxygen to prepare 2 mole of water. So the ratio between water and hydrogen is 2:2. That means 1:1, like that. But the ratio between water and oxygen is 2:1. Keep in mind. Now, which one is the limiting and excess according to our need? Let's look into here. We know the oxygen and hydrogen ratio 2:1, but here they are giving the 3 ratio 1.7. So can you guess in this ratio which one will be the limiting reagent? Simple, calculate that for 2 need 1. That means 1 mole need 0.5. Correct? If we consider like that, so 3 moles need actually 1.5 mole of oxygen. But we can calculate there, but we have 1.7. So that means for this ratio, hydrogen is the limiting reagent. Got it? This is the amount is very little, so I can just look and calculate, just look into see. But you guys can always calculate, and that we are going to see here. So for the 2 mole hydrogen, we need 1 mole oxygen. So if we consider the 4 mole, just 2 times, it will be 2 mole. Now if we consider the 1 mole, 1 hydrogen, then actually 0.5 oxygen, correct? So we have a 3, that means 2 plus 1 equal to 3. So 1 plus 0.5. So that means for 3 mole hydrogen, we need 1.5 mole oxygen, but we have 1.7 mole. So for this particular ratio, hydrogen is our limiting reagent. And how many moles of water we will make? Same amount of water we will. Sorry, I think we will make the 3 mole of water because the ratio of water and hydrogen is the same. So we will make 3 mole of water. See, without calculation, we can figure it out. But let's see how we can do that calculation. So first, the ratio of water, oxygen, and hydrogen, 1:2. So for the 1.7 mole of oxygen can fully react to make, this is the same, you have to make the conversion factor. You got it from the ratio? So we need to make the water. So how many mole of water we can make for 1.7 mole oxygen? So water ratio will be go on the top. So 2 mole water can be prepared from 1 mole of oxygen. So we have 1.7 mole. Remember the N represent moles. So this one, this N oxygen will be nullified. So we will have actually 1.7 times 2 mole water. And down we have just 1. Because this N oxygen, mole oxygen, and this mole oxygen will be nullified. So if you multiply 2 times 1.7, I hope you will get this amount. So we know first that we can prepare 3.4 mole water if we consider the amount of or ratio of oxygen. But actually no. Why? Because if we need to make this amount of water, so we need the hydrogen ratio compared to this. But do we have? Because we know the oxygen and hydrogen ratio 1:2. So that's how second time we need to be prepared calculate for the hydrogen that actually how many mole we can make. So see the hydrogen and water ratio 1:1. So the 3 mole hydrogen can fully react to make 3 mole water. So that means we don't have the enough hydrogen to react with 1.7 mole oxygen to prepare the 3.4 mole. That's why in this particular reaction, particular problem, we can only make 3 moles of water, and here hydrogen is the limiting reagent and oxygen is the excess reagent. Anybody have any question? Do you guys have any question? Everyone got it, honey? Everybody got it? Because we have this is the lengthy map next. So if you are not sure about the limiting reagent and excess, it might be a problem. So I hope you all got it. This is nothing complicated things. Let's move on. Actually, if we use the PowerPoint, then we can use the whole, but here Blackboard, we can't use the PowerPoint. But do we have, oh, sorry. Just a minute. Yeah, when I moved there, it shows the screen looking small. Okay, let's go here. No, still we cannot. Yeah, I remember because long time after COVID, we are using this platform. Just we can little bit of enhance it. That's it. If I have 3 moles of hydrogen and 1.7 moles oxygen, what species are present in the reaction vessel after the reaction is complete? Actually, we have already done it from here, but still we have another way to find the excess reagent. Let's see here. That's I'm telling that if you know the basic what is going on, you don't need to have to take too much time for your conclusion of some point that which one is limiting, which one, because sometimes you will have multiple choice questions. So it will save your times. And also you need to know the rules, because sometimes the number, if it is not so much small number, then you cannot guess it. So sometimes you need it. But most of the time, if you look the ratio, if you can correctly balance the chemical reaction, then you already got it 90% of your answer from the mole ratio. Anyway, hydrogen is the limiting reagent here, and all 3 moles react. Yes, ratio of hydrogen and oxygen is 2:1. So if 3 mole hydrogen react, then 3 mole hydrogen, and we have to put the ratio of oxygen and hydrogen, because we have to find out the oxygen, because we have the excess oxygen. So the conversion factor here, 1 mole of oxygen ratio will be go top, and the 2 mole of hydrogen will come down. And we have to multiply with 3 mole of hydrogen, which value we have. So similarly, we will go there, nullify, and 3 divided by 2, 1.5 mole oxygen will react. So if 1.5 mole of oxygen will react, that means 1.7 minus 1.5. So almost 0.2 mole of oxygen will be remaining, and this is the excess reagent in the reaction vessel. So this one, okay? Yeah. Basic excess reagent problem. So if you have 3 moles of hydrogen and 1.7 moles of oxygen, what species are present in the reaction vessel after the reaction is complete? This is the same last slide we talked, but so if you do there are 2 ways that we do here. You see, we can make the ratio with the product. It depends on what type of question asking. Here asking water, so you can do the similar math compared to product. And here asking, see that two maths are completely same, just little bit of difference. Here asking in compare with water, and here asking hydrogen and oxygen and which species are present in the reaction vessel after the reaction is complete. So here you have liberation to choose how you are going to do that. So in this type of case, normally it is suggested you can compare with the product. So same things that we last, slide we show. The oxygen, water. So in case of hydrogen, we have 3 mole. Here we go. But in the balancing reaction, we have 2 mole in compared to here. So that's why 3 times 2 divided by 2. This is our conversion factor. And for the oxygen, we have 1.7, and the ratio 2:1. Since we have the oxygen amount, so oxygen must be down, we need to write, and the top we have to write the product or water ratio 10. So you know that which reagent will be excess in the reaction vessel. You know the oxygen will be excess in the reaction vessel. So similar type of question, so many different way you can be asked. So here the last, when you do the reaction, you find the limiting, what reacts, you can also see here what reacts, and then here I want a little bit of tell something, what reacts. So 3 mole hydrogen react with 1.5 mole oxygen. I think in the beginning I told you, when I start this example. So actually here is nothing. So 1.7 and 1.5, that's 0.2, and 0.2, this also resembles to this amount of product. I mean, there are different ways that you can find out which one will be excess, which one will remain, even in a quantity. When 2.5 moles of calcium carbonate is added to 4.8 moles of HCl, calcium chloride, carbon dioxide, and water are produced by the following chemical reactions. What species is the limiting reagent in this reaction? First, look into here. Make sure that your reaction is balanced. Because if your reaction is not balanced or mistakenly balanced, then your total time you investing to solve this problem will be wasting. So we have the value of calcium carbonate and HCl. Our ratio between the calcium carbonate and HCl 1:2 if we consider calcium carbonate and HCl ratio. That means double, correct? So if we need the 1 mole calcium carbonate, then we need 2 mole HCl, correct? Double. Now if we look into our amount, what we have? 2.5 mole ratio 4.8. So theoretically, just if you look into and use your intelligence, then it's very simple that 2.5 mole calcium carbonate, you need 5 mole HCl, correct? So in this particular reaction, HCl will be the limiting reagent. I mean, without any calculation from the ratio. Got it? So this is a kind of things you will see in your mathematics, but we cannot assure that always will be the simple. So you need to know just the calculation. But remember, when we compare the ratio the way I do, this is the best way. If this type of, if we ask you to show the total math, then you have to show. But if we ask you to multiple choice question, this is your convenience how you will find your right answer, correct? You will do the long math or you will do this type of ratio. So you can find out. Now the amount of HCl limits the amount of the product that can be formed. HCl is the limiting reagent. Obviously, if the HCl is the limiting reagent, our excess reagent will be calcium carbonate, because we will have, I think, 0.2 mole extra. Yeah, 2.2, not 2 point. I think 0.1 will become, because 2.5 we need the 5 mole, but we have the 4.28. Okay, let's do here. So before the run of reaction, we have this amount. Limit calculation, 2.5 mole, and the ratio between the product. See, now look into the product. All the product are 1 mole. So that means the ratio between the calcium carbonate and the product is 1:1. Look into here. Now here I want to tell you something. In this particular reaction, you are lucky that all the ratio are 1. Correct? Calculation is easy. But if you see the ratio is not same, so maybe we can ask you the particular product to make your job. And if we don't ask, maybe you have to do 1:1 ratio. That will be the lengthy. And for the HCl, we can also do the limit calculation, 4.8 mole HCl, and if we compare to the HCl, all the product are 1 mole and HCl is 2. So this is the mole. So now we can simply tell that the HCl will be the limiting reagent and calcium carbonate will be the excess reagent, and we can see the quantitative things. So now we will know how to calculate the limiting reagent, how to calculate the excess reagent, and also how to use the mole ratio knowledge and balancing of reagent to solve this problem. Next, move on little bit of more advanced level, what we more can learn. Steps to do stoichiometry calculations. We little bit of know about it. I remember because we talked previously the mole to gram, gram to mole. Remember last year? So we know little bit of here, and it will be the for me the kind of revision. Let's see. Stepwise. So our presentation slide have stepwise instruction how to do that from the balancing of chemical reaction. So first step, write and balance the chemical equations. Second step, convert all masses from gram to moles. We know how to do that, gram to moles. You know that from the periodic table, gram atomic mass, that the for 1 mole. So if we know the amount for particular compound for 1 mole, we can convert any amount in gram to mole, correct? We just learned last week. So we can do that. This is our second step. Third step, use the stoichiometry table to find the limiting reagents and predict the moles of desired species, reactant or product. So that's why I told that we need the knowledge how to figure it out quickly, the limiting reagent and prediction of mole of desired reactant or product that we ask. Finally, the step 4, convert the moles of product based on the limiting reagent to grams of the product. So mole to gram. We know how to do that, mole to gram. So here we have also the diagram, flow diagram. So gram of a substance, use the molecular weight, moles of a substance, use the coefficient and grams, and use the molecular weight. And so you guys can practice here, but let's go back to the example. That's how I told you that little bit of lengthy, not difficult. So that's why I clear you the basic that can help you, correct, to save your time. Hydrogen, let's see this particular example. Hydrogen reacts with oxygen to produce water. We know the reaction, correct? This is our reaction. Sorry. If 8.12 gram of hydrogen reacts with 57.1 gram of oxygen, how many gram of water will be made and how many grams of excess reagent is left over? First, look into here. Don't worry, because we know the mole ratio. For hydrogen, we know the mole ratio, that how we need to calculate, because we know hydrogen molecule 2, because one hydrogen atom is 1, so 2 gram per 1 mole. And we also can calculate the amount. So in the reaction vessel, whatever we have before the reaction is this amount. Is this amount is correct? Yeah, now it's, this one is okay. When you look into this one, it's not okay, because if we consider the gram for the 2 mole hydrogen, this is actually a mole, this amount here. Anyway, for the oxygen, it will come, we have this amount. So we don't need to worry about, because this is our given amount. Yeah, that for sure. First I was little confused that, yeah. So this is our given amount, okay? 8.18 and 57.1, because this is not the 1 mole or something. So we have to convert the gram into mole. And we know that 2 gram hydrogen for 1 mole. How you know? From the periodic table knowledge, and we also know how to calculate. Like hydrogen atomic mass 1, so for 2 here, times 2. So 2 gram hydrogen per 1 mole. So 1 mole hydrogen equal to 2 gram. So this is the 2 gram. So then we can find the mole for this amount. So if 1 mole for 2 gram, so 8 gram 4 mole, but we have 8.12, so 4.06. So this is how we have to convert also oxygen. In case of oxygen, the atomic mass 16. Remember, we use atomic mass, not the atomic number. Do not confuse when you calculate the amount. For stoichiometry calculations for mass per mole, we always use the atomic mass. Atomic mass means proton plus neutron number. You will find in the periodic table, and most of the time atomic mass is the double than the atomic number. Not always, most of the times, because in case of isotope, it doesn't follow the rules, because in case of isotope, the neutron number is high, correct? So here we have to find, we know the 32 gram oxygen for 1 mole. So we can find out the mole for 57.1 gram. So our first step to convert gram to mole with the help of our ratio that we know from the balancing of chemical reaction, and also we know the gram per mole. So we can find out this one. Second calculation, the limiting reagent. In that case, let's see, without calculation, we can find out or not. For 2 gram hydrogen, we need 1 mole, 2 mole, we need the 1 mole oxygen. So that means what we have for the 2, 1. So that means 2 gram, here is 32 gram. 32 divided times 64. Yeah. So now, see, every case we cannot calculate the limiting reagent from here. So in that case, for the 2 gram, we need 32 gram. So for 8 gram, how many we need? More. So that means here we have to calculate. How? From mole and ratio knowledge. So in case of hydrogen, 4.06 mole, and the ratio between the product and hydrogen, 2:2. So we can make 4.06 mole. In case of oxygen, the ratio of water 2 divided by 1 and 3.56. Yes. So here, can you now tell which one will be the limiting reagent? Hydrogen or oxygen? Hydrogen and oxygen. See, we have the amount of mole. So in case of the amount of hydrogen, we can prepare the 4.06 mole water. And the amount of oxygen we have, we can prepare 3.56. So it seems oxygen will be finished faster here, correct? Yeah. So next, what reacted? 1.78 mole 2 divided by 1 ratio. This is between here and here. These steps you need to be little practice. So then we will find same amount here. And this is the amount of oxygen. In the vessel, after reaction, what we have? In the vessel, after reaction, we have 4.06 minus 3.56. So this amount, and which is this amount? This amount is hydrogen. Okay, so this amount will be left over. As I said, that this will be the excess and oxygen will be the limiting reagent in that case. After reaction, what we have the amount of water, this amount. After the reaction, we cannot use the coefficient because after the reaction, we have 0.5 N and 2 gram per mole. Here we go, because it left over. So after the reaction, we have this amount in gram left over, and this is our amount we have product. So now let's go our slide. This is the another one, correct? So now, did you guys find the result here? Now you got it? How many grams of water will be made and how many grams of excess reagent left over? This is our excess reagent left over and this is the amount of water. So first we need to calculate gram to mole, mole to ratio to product. We will find out the limiting and excess reagent. But here they didn't ask you the limiting, but we can ask you. So you can see the amount and you will find out. So we very sure that if we subtract the 2 mole ratio, we will find which will be the excess after the reaction. Obviously, the excess reagent will be remaining after the reaction in the reaction vessel. So this one, you have to find out from here, which one? Hydrogen. So if you compare now the amount of hydrogen per 1 mole, you can calculate the amount of hydrogen for remaining mole amount. So you find out the excess amount of hydrogen in gram. And you can also calculate the excess amount, whatever the mole we find of water. We know the 18 gram of water for 1 mole. How we know the 18 gram? Because we know the 2 hydrogen plus 1 oxygen, 16. So this is the 18 for 1 mole. We have 3.56 mole. So we can convert the gram to mole. So 18 gram per mole and this mole, this mole. Remember, MOL mole and N mole is the same. Okay, so do not confuse on that. So this is how you have to find out. So if we ask for this question like excess reagent or excess amount of product, amount of product in gram you have, you need to calculate. But if we don't ask this one, just ask the limiting or excess. So you will be do here and you will be finding your reaction, I mean answer. So you have to do for easy things. First, you know that how we have to find out the limiting and excess. Then you have to look into further what type of question you guys are asked. And if you guys are asked to find out the example we saw, remember that you have to be remember the 4 step, and that you need to be remembered the step that which is path. This is called, sometimes we say the path, that mass to gram, gram to mole, or something like that. So try to be remember here, then it will be easy. So practice here, okay? If you don't practice, as I say, second part is mostly math. These math are interesting if you practice. If you don't practice, it can be seen tough before the exam day. So please practice. This is nothing complicated, just you need practice. Calculate the maximum amount of aluminum oxide that could be produced if the 2.5 gram of aluminum react with 2.5 gram of oxygen. So that means first you need to find the balancing of chemical reaction. So you have to find out the balancing of reaction. Okay, so we have to put here 2, here 3, and here 4. Correct? This is the reaction. So it seems what information we have? We have aluminum and oxygen, that amount is same. But aluminum and oxygen ratio is not same. Correct? So aluminum amount is higher than oxygen. So that means here it's very simple, the aluminum will be the limiting reagent. Got it? Any questions? So because 4:3. So even if we consider the mole to gram, we don't know, we have to calculate for that. So let's go back and do the calculations. First, we need to write the balance equation for the reaction. Next, we need to determine which reactant is the limiting reagent. Then, let's see here. So 2.5 gram, 2.5 gram, we write our balancing equation. First, convert the amount into mole. Yes. Yeah, sure. Question? Any question? Yeah, you can ask. Don't shy.
I think somebody asked a question on the blackboard.
Oh, it comes from here?
Yeah,
Blackboard?
people are able to talk to you from there.
Oh.
Yeah, somebody...
Okay, who asking me question from the blackboard? It's okay. Let's move on. Oh, really?
Yeah, you can also talk to them.
No, I don't want to talk to them because they're supposed to be here.
Some of us can be sitting.
Yeah, so they can ask us. It's okay. Okay, follow here. 9 students are here. We understand maybe they don't have recitation today, so they think that we will not go. This is the disadvantage of recorded, because it's very simple that if you don't have points on the attendance, so sometimes the students do, but still the classroom is classroom. Anyway, if you have question, guys, you guys can also ask me. I was just joking. Anyway, let's do that. So our job here, first step, gram to mole. Second step, use the mole information and the ratio to calculate the limiting reagent. So when you calculate the limiting reagents, always use the ratio with the product. So aluminum and aluminum oxide ratio 2 divided by 4. So we know that whatever the amount of aluminum we have, we can produce this mole of aluminum oxide. And whatever the mole of oxygen or amount we have, we can produce 0.052 mole. So it seems the aluminum less amount. So we can produce the aluminum here limiting reagent. Now, If we subtract this amount, we will find that which one will be the excess. But this is here didn't ask you, correct? So just for your information. So in the reaction vessel, we will have this amount. So they ask you the maximum amount of product. So this amount is the maximum amount of product. So next job to convert mole to gram. How we can do that? Mole to gram, we know if we know calculate the atomic mass and use the atomic mass, we can calculate the amount of aluminum oxide. In that case, we don't use the coefficient. So please do not confuse here. So Al2 and O3, if you calculate, you will find the 101.96. Let's just give you a little bit of review. Periodic table. So where is aluminum? Here we go. Aluminum is 26.9. That means almost 27. And oxygen, we know that this is 32. Oh, sorry, 16. So in that case, go back to our job. So we have 2 moles of aluminum. So we saw 27 times 2 plus 16 times 3. So if we count, you will find 101.96 gram for 1 mole. So we have this amount of mole. So we will find the final gram amount that we will got for this mole. So this is the answer for this particular reactions. Consider the reaction the nitrogen plus hydrogen make ammonia. If you react with 14 gram hydrogen with 56 gram nitrogen, how much ammonia can be formed and how much excess reagent is left over? Your job is same. First write the gram, step 1 gram 2 mole, step 2 limiting reagent. So you have to be consider the ratio with the product. You have to calculate the ratio with the product. When you will see the mole, N represent mole, remember 4.74. That means nitrogen is the limiting reagent here because nitrogen can produce only 4 mole, but hydrogen can produce 4.7 mole. But if we don't have enough nitrogen, it does not make sense, correct? So we have 2 questions. How much ammonia can be formed and how much excess reagent? So excess reagent 4.7 minus 4, correct? 0.7. So those 0.7 is here. So you can subtract what reacted and you can find out. Here we go. This amount, 1 mole we have remaining because here we have the 4.7 mole and this is the 7 mole hydrogen. What reacted? 2 mole reacted. Okay. Here reacted 3 divided by 1. Yeah, this ratio. 6 and we had the 7. So 7 minus 6, 1. And we find this amount and this is our product amount. So this is the same thing that we did here. Not in this reagent, this here we did. Here we did. This is the same types of reaction problem. So please do the practice. Okay. So before going that, so this was the first part of the today's lecture, topic 14, that how we can find what is the limiting reagent, what is the excess reagent, and how we can apply our stoichiometric knowledge on the balancing of chemical reaction, and we can find out all those information. Second part, we have percent yield of a reaction. Now, when we start the chemical reaction, we calculate according to the balancing of equation and we set the amount. We consider that if our reaction go correctly, our yield will be maximum 100%. And this is our theoretical value. But sometimes there are so many reasons we may not get the 100%. Why? Because sometimes when we handle the reagent, we take the weight from the weighing balance, correct? Often student can be, anyone can be do mistake little bit of less or little bit of more. So in that case, sometimes even percentage can be little bit of more 100. So can be like plus minus 5 is accepted is based on what type of reaction we are doing. Normally it doesn't, normally less, but so we have then the percentage knowledge we need, that what is the theoretical yield, what is the practical yield, like that. So those type of knowledge or how we can calculate those type of percentage we will be discussing here. Let's consider the reaction example. This is very famous example for this presentation, nitrogen plus hydrogen, ammonia. If you react 14 gram hydrogen with 56 gram nitrogen, how much ammonia can be formed and how much excess reagent is left over? See, now little bit of not easy, because now they are not asking you the mole. Now they are asking you gram, correct? Because if they are asking you mole, the ratio finding is very easy. But when they are asking you gram, that means you need to calculate the gram also here. This is also kind of, sometimes people do to save the time, just to calculate the nitrogen and in gram, because nitrogen I think 14. So here is a 2 nitrogen atom, 28. Hydrogen is 2 plus 3, 6 gram. So it means that 28 gram nitrogen actually react with 6 gram hydrogen. This is the unofficial way. This is just I'm sharing. We have to follow the rules. So 28 gram nitrogen for the 6 gram hydrogen, actually. So here if we look into 14 gram hydrogen, 56 gram nitrogen. So 28 times 2, I think 56, correct? Yeah, 25, yeah. So 56 gram of nitrogen actually will be 12 gram of hydrogen, but we have 14 gram hydrogen. So still I find out very shortcut that nitrogen will be the limiting reagent. Got it? This is also the one way to find out. But let's see how we will do according to our rules. This is also we can find out to save the time. Alternate way this is, okay? So let's see how we can do that. By limiting reagent calculation, we found 68 gram ammonia. Okay. In this 68 gram ammonia, they got it, and the yield is 100%. This is, the same that we did last time. They find the 68 gram. They told you, okay, let's see. Even if you calculate, we can find it. So this is called the theoretical yield. Now the actual yield is only 30%. Actual yield is only 30%. How? Because if your reaction runs perfectly, you should get the 68 gram. But you got only 20 gram. Now got it? According to our balance reaction, we calculated this amount of hydrogen, this amount of nitrogen, and we know that if reaction proceeds, it should be 100% and 68 gram. But what happens sometimes when we do the filter, when we dry the sample, transfer from one balance and one reaction vessel to another, we lose the product. Sometimes when we do the separation, filtration for the different solvent layer, this is also one major way we lose, and this is very normal in the chemistry lab. Okay, so there are some way commonly we lose the amount. So it doesn't mean that maybe the reaction proceed, maybe the reaction was not so low percentage, but due to my handling, I used the product. So this is the efficiency as a technician, as a researcher, a student needs to build up. That doesn't come in a one day. So that is the actual yield. How we can calculate? Same, that whatever the theoretical amount for 100 and 30%, that means 30 divided by 100. So we can find the gram. Or even if we have the gram, just we can calculate the this amount compared to 68 and do the percentage of 100, we will find the percentage. So let's go back to this. See here. So normally, as we said, we use this equation, percent yield equal to actual yield in gram, theoretical yield in gram, that 100 times 100. So then you will find percent yield. As I said, just that 30%, 40%, 70% or 80%, you will find it. Based on theory, stoichiometric table. So where we got the 68 gram? That we got the here. We learn here, 68 gram. Got it? We learn here. So actual yield based on what you actually produce in the lab. So we can find out here. How many kind of yield are there? We have actual yield, we have theoretical yield, we have percentage yield. Theoretical yield we got by using our stoichiometry table. Actual yield, what we do after the reaction, and we got. And the percentage from here we can got it. So there are three types of yield. So actual yield, the mass of the product that you actually produce by doing a chemical reaction in the lab. Theoretical yield, the mass of the product that you predict based on stoichiometric calculations, the largest possible yield of a reaction. Percentage yield, ratio of the mass of actually you got divided by theoretical value we got from the stoichiometry chart and times 100%. So then we can get it the percent yield. Got it? There are three types of percentage. Percent yield calculations. Example. Calcium CaC2, this molecule is called calcium carbide. Is produced, you know, there are some country, not only, I mean, most probably the developing country, there are in the world, some people do some business people do the malpractice, like this calcium carbide is used to ripen the fruits faster than banana especially. I'm not sure if United States they use it or not, but especially the fruits we buy, if you think that long time storage in your home is still it's okay, that means they have some chemical. Because natural fruits cannot be at least the right condition cannot be survived long, correct? So make sure that if you buy something, we often see the apple and orange in our fridge 2 weeks, 3 weeks, 4 weeks, 5 weeks, sometimes same. That's not good. So if you see some vegetables and fruits like how you can get rid of these things, take a bucket of water, put some salt, and sink your vegetable within the salt water, and half an hour or 1 hour, you guys can little bit of get rid of those dangerous chemicals. We know little about this because, like as I said, I'm Asian. The Asian part is very poor and developing country. Some the how to say dishonest everywhere, but more less or more. And over their country is small, so many populations. So sometimes, and also the environment is very hot, not like our United States. Sometimes people use. And I believe United States also, because I often see the especially fruit. Even the big supermarket fruit, you will see the apple outside is glassy, very glassy and polishing. I mean, it looks so, what to say, like gold, like shiny. How they use chemical to make this shiny. So he always suggested don't eat always peel the vegetable or fruits before eating. Because when you peel the vegetable or fruit, you are obviously you are saving yourself from some of the chemicals. And also, it is good that if you wash, we know the water soluble vitamin, if you wash the vegetables too much, it goes away. But still, before cutting the vegetable, people should wash it. And also, if you boil, at least you boil and eat, that's good for your health than the raw vegetables. Nowadays we very cautious about our health. We eat lots of salad and raw. But remember, when we cook, heat also destroys some bad chemicals. Anyway, let's do our job. So calcium carbide is one of the chemicals that used to ripen the fruit. It's produced by the reaction of calcium oxide and carbon to produce calcium carbide and carbon dioxide. If the reaction goes in 85% yield, how much calcium carbide can be produced from the 16 gram? So you need to know the stoichiometry, correct? So first you have to do the balance the chemical reaction. You have to find the theoretical yield, and then you will find the actual or percentage yield, and then you guys can find it out. So here we have to do the same thing that we done. See, limiting what react, after the reaction what we have, and then we will have our percent yield, we will find the gram. So this is our theoretical yield 17.9, and this is our actual yield, because actual yield divided by percent yield equal to actual yield divided by theoretical yield. So we can find out like that. Okay. An old exam problem to use. Okay, this is maybe somehow it came in the previous year's exam. So as I said that please know the step by step, and even you may have your format. What you can do, you can just draw your format and you can take a print or keep it with you. That can also help you when you do the practice. It's totally up to you how you will practice, but you need practice because obviously your question will be multiple choice question. You will have time, but you need to do that, correct, and find the answer. Dinitrogen pentoxide can be made by reacting nitrogen gas with oxygen. Same thing. I'm now tired to say the same thing again and again. So you have to do the gram to mole, then find the limiting, and obviously when you do the limiting, try to get ratio, then subtract, and then you will find which one is excess. So you can convert the mole to gram, and you can calculate the actual yield by using the calculation. So please practice here. Consider the chemical reaction that occurs sodium plus oxygen, sodium oxide. How many grams of sodium oxide are produced when 5 grams of sodium and 5 grams of oxygen react with and yield? Okay, so you have to do the same thing, but if you look into the amount and look into the ratio, I think you will able to guess that which one is your limiting. But in this case, you have to do that because you have to find out the gram. So follow the same thing. This is your path. This is, we also say the path. Sometimes we provide you the path. If it is too big, in the question hint section, we give you the path so that you guys can do that easily. Obviously, if you have this type of math, the point will be 5 or something like that. Here we have the another one. Yep, so that was the all. We have the more practice. You know, this is supposed to be the question, but still I give you. So if you practice, that should be the enough for this chapter. So that's all for the topic 14. I think you don't have, I thought that you have to also do the how to calculate the each percentage of the reaction. So actually you don't need, because if you need, then I should give my supplement material. But that's also, you don't need anything else. That's all for today's topic. But we will do our recitation. You remember for the section 1, we will do the 5 and 6. Let us right?